Good day, grade 11s. Welcome to today's trigonometry lesson. So what we're going to do today is general solution combined with a specific interval. A general solution in a specific interval. What do we mean by specific interval? Our x, or our solution, must exist between minus 180 or between 0 and 360. We've done one before. Or between minus 360 and 360. And the problem that we specific going to look at is the 6 sine square x plus 7x plus 2 equals to 0, where x exists between minus 360 and 360. Right, so let's see how that's going to develop. I'm going to move over to my desk and just stay tuned. I'll be with you just now. Right, let's see how we deal with this problem now. What we have is the 6 sine square x plus 7x sine x plus 2 equals to 0, and x must exist between minus 360 and 360 degrees. Right, one tends to think, well, perhaps we must take the 2 over to that side, but then I'm left with a 6 sine square and only a sine, and that's not going to work. We cannot factorize it so that we can have a 0 on the right hand side. So what we see is this exponent here is a square, and it's double the size of this one over here. So it looks like a quadratic equation. To simplify it a bit, let's do the following. Let's say let k be equal to sine x. Okay, so see what's going to happen now. This will simplify it a bit. So instead of a sine x, I'm going to place a k in sine x place. So what we have is the following. We have 6, not sine now, but k squared, because I have a square there for the sine, plus 7k, there's only one sine, that's over there, plus 2 equals to 0. So what we do is we can see if we can factorize this now. Okay, let's try it this way. We see we have, we're going to have 2 brackets over here equals to 0. Okay, we have a 2 that's plus, and that is a plus, so it means we're going to have a plus 1 and a plus 2. Now we need to get a k value there and there. So let's see how we're going to deal with that. So the factors of 6 is 6 times 1, or it's 2 times 3. And if we do it this way and say, well, let's try a 6 there, a 6k, and a k there, that gives me, if I multiply that, it gives me a 6k square. And there I have my 2 and I have my 1. Okay, let's see if I can get my middle term now. So if I multiply that, it gives me 12k. If I multiply these two, I get a k. If I add it, I got a 13k. So no, this is not going to work. This is not my middle term over there. So let's try the following. So let's put a 2 there, and we put a 3k over there, and see. So it's 2 times 2 is 4k, and 3 times 1 is 3k. If I add these, I have a 7k. So that is my middle term over there. So in this case, I will say it's 2k plus 1 and 3k plus 2. 3k plus 2. And that we can solve very easily. So in this case, we can say that 2k plus 1 is equal to 0, or 3k plus 2 is equal to 0. And that's a very simple equation so that we can solve. So in this case, k is equal to minus a half, or k is equal to, if I take the 2 over to that side, it becomes negative as well. It's 2 over 3. So we have 2 solutions over here. So let's start with this one over here. So we have a k equals to minus a half. So instead of a k, we can substitute it back with the sine x. So what we have is sine x is now equals to minus a half. And that we can solve very, very easy. Right. The first thing we need to do is to calculate my reference angle. And that is the sine inverse sine minus 1 of positive a half. Your reference angle, you always calculate with the positive value of your answer over there. Never your negative value. That works for your reference angle. We will deal with the negative just now. Right, if you use your calculator or you use your special angles, then you will see that this will come to 30 degrees. So let's emphasize that a bit to make sure that we will remember this. So my reference angle in this situation here is 30 degrees. We will deal with that one just now. Let's continue with this now. Right. Another thing that we need to see here is the following. I need to decide where my solutions will lie, in which quadrant, the first, second, third, fourth. And now we're going to make use of this sign over here. Sine x is negative. Now where is sine negative? Sine is negative in my third and in my fourth quadrant. And remember, in my third quadrant, I work with 180 minus. And in my fourth quadrant, I can work with either minus theta or 360 minus theta, or x for that matter. Okay, but let's deal with the third quadrant first. So in my third quadrant, I'm working with, not equals, that must be x equals to 180 plus my reference angle of 30. Okay, and now I add my general solution, n dot 360 degrees. Why do we do that? Just remember, if that is my solution, if that is my place or my angle where x exists, it is that. If I should add another 360, I will get exactly to the same position. That is why we need to add 360 for my sine x in this situation. Right. So x is equal to, now 180 plus 30 gives me 210 plus my general solution. Good. My fourth quadrant. Now, instead of 360 minus x, I'm just going to work with minus my reference angle, minus 30. Why is that? If we look closely, then we will see the following. That is minus 30 degrees. That's exactly the same position if I measure it the positive way. If I measure it positive, I will get a 330. But it's exactly at the same position as a minus 330. We do this with our general solution and specific solutions because it makes the calculations at the end much easier. So we're going to work with minus 30 degrees for this now. And then we also need to add my general solution as well. And yes, well, okay, that's what we have there. Good. That's simplified as far as we can go. Right. So that was the sine x equals to minus a half. Now let's deal with k equals to minus 2 over 3. We will get to the specific solutions just now. First, we need to calculate the general solution first. Right, first of all, the reference angle for that one. Okay, and the first, let's write down sine x equals to minus 2 over 3. And now we can calculate my reference angle, the sine of minus 1 of also positive 2 over 3. My reference angle, I always calculate positive. Now let's see what is this. So we have shift sine of 2 divided by 3, close bracket, and that gives me a 41,81. 41,81 degrees. That is my reference angle. So let's emphasize it as well. Let's put it in a little square over here. That is my reference angle for my second one. Good. All right, let's continue. Again, we see that sine is negative over here. Where is sine negative? In my third and in my fourth quadrant. So my reasoning is exactly the same here. I'm going to work in my third quadrant. X equals to 180 plus my reference angle 41,81, and just add my general solution as well. And if I add these two, so it's 41,81 plus 180 gives me 221,81. 221,81 degrees plus my general solution. Don't forget about that. So that is my third quadrant. So let's go to my fourth quadrant now, because that's also where sine is negative. So it's x equals to, and now the same reason, I'm not going to work with 360 minus, I'm just going to work with the negative reference angle. In this case, it's minus 41,81 plus my general solution. There we go. So we have these two, actually four type of solutions here. Now just remember these values over here, that one, this one, that one, they refer to as my general solution. That is my general solution. But I need to calculate the specific values between minus 360 and 360. Okay, minus 360 and 360 degrees. Right. Now to get the specific values, it's actually very simple. A little bit time consuming, but it works quite well. We need to substitute n equals to 0 now. Remember, that's my general solution over there, meaning I need to substitute n equals to 0 because n is element of my integers. Okay, here as well. N is element of my integers. So let's start with 0. That's the easiest of them all. Right, so if we substitute 0 into this one over here, that's very easy. So that just falls away, and my answer is 210 degrees. Let's have a look at this one over here. That will fall away, so I will have a minus 30 degrees. Now, ask yourself, okay, does this exist between minus 360 and 360? Definitely, right, both of them. Right, let's go to this one over here. Substitute 0 in there, that falls away. So I end here with, okay, I've already got it, sorry. Okay, let's go to this one over here. Substitute 0 in there, that falls away. So I have an answer of 221,81 over there. If I substitute 0 in here, I'm left with minus 41,81. Okay, right. Okay, and both of these also exist between minus 360 and 360, 100%. Now, what we do, let's go to n equals to 1 now. Let's start with this one. Okay, remember we need to stick between minus 360 and 360. So if that sub n comes 1, then I add 360 to 210, and that will go beyond 360. So I'm not even going to bother writing that down. This one over here, minus 30 plus 360, yes, that will work. And that gives me an answer of 330 degrees, and that exists between this interval over here. Okay, let's go to this one over here. The same. 221 plus 360 will go beyond 360. Not going to bother about that. But this one over here will give us definitely an answer. So we will have a minus 41,81 plus 360, and that gives us an answer of 318,19. Okay, that works fine. Good. So we've dealt with that now. Now we go to n minus 1. So we substitute n minus 1 now. Okay. Let's start with this one again. That will become negative, that 360. I think that will work. So let's see. We have 210 minus 360, and that gives us an answer of minus 150 degrees. And if I'm correct, that's between minus 360 and 360. Let's go to the next one. If that becomes a negative 360, because I'm substituting minus 1 in there as well, then I'm going to get a minus 390. And that will be to the left of 360. I'm not going to write that down. Let's go to this one over here. Okay, I think this one's going to work. If that becomes negative, let's see. We have a 221,81 minus, it's going to get negative, minus 360. And that gives us an answer of minus 138,19 degrees. That works. Okay. Now, if we check this one over here, if that becomes negative, negative 316 minus 41,81 will be to the left of minus 360 anyway. So it seems to me this is a lot of them. I'm not going to bother to rewrite them all. All I'm going to do is this. I'm going to do this. I'm going to do that. Put them in square brackets, and then I'm going to say x is element of that. Not going to rewrite them all. Right. Thank you, grade 11s. All the best for the rest. I hope you get it right. Thank you. Good. Thank you, grade 11s, for watching the video, and I hope you have a great day. Goodbye.